have looked at the theory of how the Earth was formed. Now we're going to discuss the theory of how petroleum is made and accumulated. In this lecture, we are going to talk about types of rocks. In the rock cycle, we have three classifications of rock: igneous, sedimentary, and metamorphic. We identify these rocks according to rock type. Of course, the UAE has all three classifications, but in this course, we will focus on the sedimentary rock because only in that rock oil is found. We can further divide sedimentary rock into additional types: carbonate, which is limestone, and silicate, which is sandstone. Carbonate rock was formed by chemical composition when the layers that were laid down to form sedimentary rock contained remains of living things like shells and coral. Here is an example of carbonate rock called limestone in the UAE. Silicate or sandstone was formed when the layers that were laid down contained silicate particles of varying sizes. Around Liwa, you can see examples of sandstone. In the UAE, most of the oil is found in limestone. Here is an animation of the rock cycle. We start with magma from erupting volcanoes that comes to the surface, cools or solidifies into igneous rock that over time forms mountains. The igneous rocks in the mountains are exposed to the wind and water, which begins to break down the rock. This is called weathering. Over geological time, these particles are transported by the same wind and water to another location. This is called erosion. Eventually, these particles and pieces of rock settle in a quiet place like the bottom of the ocean, where they accumulate into sedimentary layers. As the layers increase, the pressure and temperature increases on the lower layers, causing lithification, a transformation from sedimentary particles into sedimentary rock. Lithification can be formed by compaction, which is a physical process, and by cementation, which is a chemical process, a chemical change within the physical process. Remember, sedimentary rock can be transformed by these three processes: physically, or chemically, or a combination of both. Meanwhile, as the plates at the margin continue to move, because they are dynamic, always moving, some of the sedimentary rock is pushed down by convergent plate movement. When this subduction, which is when one plate pushing down under another, occurs, the rock is pushed closer to the mantle. All that friction of rock pushing and rubbing against each other causes a lot of heat. This heat changes the minerals into different shapes and combinations, creating metamorphic rock. Then, because some of this metamorphic rock is pushed further down, it gets so hot it melts, forming new magma, and the rock cycle starts over. Igneous is mostly crystallized or cooled parts of magma. Sedimentary is weathered and eroded igneous rock deposits that have formed layers, been buried, put under heat and pressure, and lithified, physically, chemically, or both. Finally, metamorphic rock is formed when the plate margin movements causes rock to be pushed down and transformed. As I said before, in the oil industry, we care mostly about sedimentary rock because that is where the oil is, where we find the hydrocarbons. The presence of hydrocarbons in sedimentary rock is why we search for this type of rock. But the oil industry is not the only one interested in sedimentary rock. It is in this rock that we find all our minerals. We find gypsum, used in the building trades. We find gold, silver, and copper, used in all kinds of manufacturing as well as jewelry. The phosphates fuel the petrochemical industry. In this rock, we also find salts, a mineral needed for us to sustain life. Therefore, sedimentary rock is essential to us in our way of life, giving it tremendous economic value. This is pretty impressive for a rock, don't you think? Here is a chart showing the composition of sedimentary rock. As you can see, most of it is siltstone, mudstone, and shale. These other two, the two important ones, are limestone and sandstone. These are the two that contain most of the oil, where the oil reservoirs are found. Sandstone is generally more important in the United States, Mexico, the Gulf of Mexico. Here in the UAE, they have very little oil-producing sandstone. Now let's go back to the rock cycle for just a moment. We saw the molten rock appear as magma that is then cooled into igneous rock. It was exposed to weathering and over time broke down, causing it to crack and separate. Erosion next moves these cracked and separated particles away to some other place, causing them to get separated into smaller and smaller particles. These particles eventually are deposited on the bottom of the ocean into sedimentary layers. As the sedimentary layers are lithified, they form into sedimentary rock in two different ways. Some are transformed by deposits, which is a physical change, which we call deposition, chemical change, which we call precipitation. In the physical change, sedimentary layers are piled on top of other layers until they are squeezed, compacted, and turned into rock. Within this physical change, you can also get a chemical change called cementation. This is where grains in the rock mix with water, causing them to bond or cement together. Do not confuse this with precipitation, which is also a chemical change. In precipitation change, or chemical change, particles are actually formed. In carbonates, for example, particles are formed when carbonic acid plus calcium ions are mixed with ocean water. Depending on temperature, they solidify back into solids, precipitating out of solution and forming layers of sedimentary rock. Within physical change in sedimentary rock formation, I want to mention clastic deposition, which is a classification based on particle size. As you can see in the animation, the energy of the water flow carries sand and silt grains, pebbles, rocks, all various sizes, and deposits them on the bottom as the energy decreases. As the water slows down, the heavier particles are dropped off first, with the smaller ones being carried a little further until all are eventually dropped and deposited, creating clastic deposition. In this river delta, you see these streams and rivers carrying sand, silt, and rocks to the ocean. As these particles get deposited into layers and are buried, pressure and temperature turn them into sedimentary rock. As these particles get deposited into layers and are buried, pressure and temperature turn them into sedimentary rock. So let's review. In making sedimentary rock, you can have either sandstone or carbonate. Usually, when sandstone is converted to sedimentary rock, there is a physical process called deposition. Further, within this deposition, you get a chemical change called cementation. Limestone or carbonate sedimentary rock is formed by a chemical change. This is called precipitation. Now, using data collected on the ocean floor, underneath the earth and at the earth's surface, geologists build maps, surface and underground. They map out the kinds of structures that are present. They are looking for the formations, layers of rock extending over a broad area. What kinds of formations are they looking for when they are looking for oil? There are a couple of basic ones. On this map, the formations are identified. Let's look at the depositional processes and environments in more detail. The first are carbonates. Here you find the dunes. If you find an ancient dune, you will probably say that the weather there was dry at the time it was deposited. Meandering and braided rivers or riverbeds can be identified by the size of the boulders or the rocks that were deposited by moving water. If we find big rocks, we say the water had high energy, that the water moved fast. If we find a lot of mixed, small ones, we say that it was a big, wide river moving slowly. Here we have an alluvial fan. Alluvial fans are fan-shaped deposits of water-transported material and typically form at the base of a steep slope. Coarse-grained, especially at their mouths, they tend to be relatively fine-grained at their edges. Deltas, or river plains, are crisscrossed with rivers and streams of slow-moving water. There, large plants like trees and animals flourished. If you find very small silt particles, you will probably be looking at a lake bottom. At one time, these lakes were underwater. Something altered the source of this accumulated water, causing it to evaporate. In these ancient deltas, you can find minerals and hydrocarbons, like coal. In fact, if you were a coal mining engineer, you would look for ancient deltas. Here we have beaches. What is interesting about beaches is that they have been bombarded by steady waves, so the sand grains are almost always the same size. We call that well-sorted deposition. They are all uniform in size because they have been ground down by the energy of the wave action over a long period of time. When the water subsides and the waves stop, the sand on the beach gets buried, compacted, or lithified into sandstone. This is a good reservoir rock. Shallow water carbonate platforms, like reefs, are very important formations where we can find oil, especially here in the UAE. Here is an example of a reef. It is made up of coral and oceanic animals and plants. After these plants and animals died, their remains were buried and settled into sedimentary layers, lithified, and became sedimentary carbonate rock. They are formed in tropical or subtropical shallow oceans where life was plentiful. This rock also makes very good reservoirs. Exploration geologists always get very excited when they find reefal formations because these formations could contain another large oil field. There are three types of reefal platforms or formations where we can find oil. The first is at the reef's platform edge, made of strong shells and oolic banks with high wave energy. These can form into long reefs that extend along the ocean shore. Sometimes they also break off, fall into deep water, and are buried. The second carbonate platform is found at the edge of lagoons. Lagoons are saltwater inlets protected from big waves. The plants and animals there, which are different from the ocean, also die and are buried, building reefal formations in the mud and shells found. The third type of platform is formed by carbonate slopes made from grains from reefs and banks, carbonate mud and carbonate mud flows. Here's another reef. Oceanic plants and animals like clams and other shellfish, grow and die there, creating reefs from their crushed shells that grow out of the water. Eventually, silt and sand accumulate, allowing trees and other land plants and animals to grow until these reefs become little islands. Sapkas are abundant throughout the western region of the UAE. They are also important formations for petroleum geologists. Sapkas are formed when water accumulates on salt flats and then evaporates. This leaves a white layer of sulfates made up of anhydrite and gypsum. When these sulfates evaporate out, you get three layers of material: anhydrite, gypsum mush, gypsum crystals. It is these three layers that define a sapka. What is interesting about a sapka is these hard layers are impermeable to oil and form a seal or trap. Many times we find oil trapped under sapkas. Again, geologists look for underground sapkas. As we described earlier, weathering and erosion cause sediment to be transported to the oceans. There, at places, this sediment builds up at the ocean's edge where it creates a continental shelf. Eventually, the weight of this sediment shifts, causing landslides that form submarine fans. finer sediments are found on the outer fan edge.